It's time for Pure Performance.
Get your stopwatches ready. It's time for Pure Performance with Andy Grabner and Brian Wilson. Hello and welcome back to part 2 of our talk with Pat Meenan from Google. Just in the previous talk, we were discussing machine learning and figuring out why you have bounce rate, what's contributing to your bounce and conversions. And besides machine learning, what was the kind of tree we were talking about, Pat? It was something tree. I forget the first name.
Random
sorry,
forest.
Yeah, it was a tree visa.
Another form of machine learning.
That's why I was thinking tree. So welcome back, Pat, and welcome back, or not welcome back, Andy. You're always here. We're always here. We live in our headphones here. So I think we want to switch to the topic now. Well, before we go into the topic, we wanted to try to introduce a new segment here, Pat, and you're kind of our guinea pig on this. So we apologize for, not knowing you super well, but subjecting you to this. We want to get into the habit of asking our guests, kind of some of the biggest or most embarrassing mistakes they've made in the past, and maybe what they've learned from them. Kind of illustrating that we all do some goofy things, but usually there's a great learning from that. So with that, Pat, what would you like to tell us about yours?
Yeah. So, I mean, it's not all that embarrassing, but I've made more than my share of mistakes over my career, and I think probably the one that stuck with me the most, it's around memory usage. And so when I was back at AOL, one of the things that we got harassed about a lot was in Task Manager how much memory the client was using, and I was on the client team at the time, and and it's not like you don't see that these days where everyone's sort of focused on how much memory browser X uses, right? And so at the time, Task Manager in Windows, it still reports working set, not like total RAM allocated or anything like that, which is roughly how much memory is being used by the process right now. And you could actually, there are APIs to page out your process, which basically gets rid of all of the RAM that it's using, and then Windows will page things back in as code runs. So it doesn't drop down to 0, but it drops down really low. And how often you call that sort of maintains how low you can keep the memory looking. But it's a horrible idea to do for performance because you're paging your code in and out all the time when you're doing that. And maybe something that's not accessed really frequently is paged out where it could have been a lot faster if it was in the RAM, and systems have tons of RAM for these caches. And so I've sort of learned from that, and we shipped it. I mean, I wouldn't be surprised if the AOL client didn't already or didn't still for people that are using it after certain events, like after you make it through the sign-in flow, it'll page itself out just to get rid of all of the code from the sign-in flow and things like that. But I've since walked back from that a lot just because your system has a lot of memory. Optimally, the programs running on your system would use every last bit of it to make the performance of your user experience as good as possible. You just don't want it to need all of that memory. So it would be nice if your browser ran on 16K of memory, but if you had 16 gigs of RAM, it would use all of that for caches, and it would be lightning quick and everything else. So now whenever I do get frequent requests for people asking me to add like memory tracking or memory usage to WEBPAGETEST, and I always push back really hard because for the most part, it doesn't make sense. You largely want your apps to use 100% of the available memory as long as they're being good citizens about it. And historically, that, at least for me, has been the biggest code mistake I've made that I've learned from and sort of taken with me over the years.
Well, thank you very much. That's a great one.
Yeah, I think so too. A lot of lessons learned. A lot of thanks for sharing, because I think opens up all of our minds about this problem. And thanks for being open to sharing it with a large audience. Cool.
All right, so on to the next main topic of web performance. And Andy, I think you had a lot of different concepts you wanted to talk about. I don't know. We wanted to talk maybe a little bit about his other velocity talk, but there were some other things. I don't know if there was any you wanted to tackle first.
Yeah, well, basically, in the previous session, we talked about finding out how much we need to move the needle of page load time or performance in order to improve conversion or reduce bounce rate. Now, Pat, I know that you and Steve and a lot of other people talked about web performance optimization over the last couple of years, and it's been around for a while now. The first thing that I would actually be interested in is, so what has changed in the last year or two, especially in the advances when it comes to new browsers, new capabilities, obviously a total shift in the way we write applications, right? We're talking about single page apps. I mean, I know this is a broad topic, but basically what I would like to quickly understand for our audience that might be new to the topic and they read Steve's book on optimizing websites.
And just to clarify, that's Steve Souders, because if they don't know who he is, they should learn.
Yeah, they should know him. So if people are getting new at Googling for web performance optimization, they probably find his books and some of your blogs of your earlier posts. But what's new now? What has changed in the last year or two? And what are the new the quick tips and tricks that you would tell somebody that is new to the space to look out for, besides obviously what is still relevant when we look back 5, 6, 7 years in the early days when Steve said reduce the number of round trips, optimize your images. What else is there?
Yeah, and so I'm glad you threw that last bit in there because, there's a lot of new stuff going on, but the old stuff is still relevant, and it's actually probably the most critical. So make sure you do all of that stuff first, and then play with the new, shiny, exciting stuff. Because I can't tell you how many sites I look at where it's a little discouraging after the last 8-10 years or whatever, where we're still talking about, look, we need to fix all of these basic things still, and there's still all of the same problems recurring. But let's assume you've got all of that stuff taken care of. You're serving well-compressed images and keep alives and all that kind of stuff. It's a really exciting time in browsers these days, or even just the web in general. HTTP2, easily one of the most exciting bits for me, and I think for the web at large. And I think even though, the protocol shipped, it's been stable for the last year, and even before that it shipped as Speedy, we are still very early in the days of HTTP2 and the optimizations for it, and probably get into a lot of that later because I think that's going to be a huge area for differentiation across like CDNs and accelerators and even web server infrastructure.
Do you happen to know what the adoption rate right now is of HTTP2?
I don't. And it's also
hard to say, probably, right?
It's one of those things that's a little hard to say because you've got a lot of what we look at, like within Chrome, for example, is we look at the usage by page views, and those are going to be heavily skewed towards people visiting Google, Facebook, LinkedIn, Twitter. And once you get past like the top 5 or 10 sites or whatever, you've got 90% of the page views. And I mean, out of all of those, the vast majority of those are already on HTTP2 and already HTTPS only. So there's a huge adoption as far as global page views go. Even looking at the long tail, you've got sites like Cloudflare, which is doing SSL for everybody, and they automatically do HTTP2. So as a lot of the core infrastructure takes care of the upgrades for you, you see large swaths of the internet migrate to it. For the sites that aren't HTTPS yet, that's the biggest section where they're obviously not HTTP2 because one requires the other right now. I don't know how I feel about it. I'm kind of split between it's not sort of the open web, but it solves like all of the performance problems for a lot of the sites. Is the AMP, the accelerated mobile pages, where assuming you write AMP content, it's edge cacheable by whoever's serving the AMP pages, and it's guaranteed to be optimized. So you've got guarantees that there's no server response time issues. Certainly in the long tail with shared hosting and all that kind of stuff, that's one of the biggest problems I still see today. So that all goes away when someone like Google or LinkedIn or whoever is serving your cached version of your page automatically for you. And even though you can build faster HTML pages by hand than you can with AMP as a platform, AMP is guaranteed to not do slow things. So you also have guaranteed fast user experiences, even if it's not necessarily the fastest user experience possible.
Can you
get like optimized images and stuff.
Can you quickly, for people that don't know AMP, where could they find more about it? I guess Google for AMP.
So if you Google for accelerated mobile pages is probably the best search term to use for it. There's a GitHub. It's all open source. It's a GitHub repository, and it's a restricted set of Markdown that you can use in HTML, where like script tags aren't allowed. You're only allowed to use other AMP modules, and those are vetted JavaScript libraries that don't do bad things, like document.write is sort of the quintessential, God, if we could only undo that from the web, everything would be better. But so there's like a curated set of libraries that you can use that do just about everything. They've got like image galleries and video players and analytics beacons, and sort of all of that kind of stuff come as available prepackaged modules, and usually callable out to whatever service you want to use. And since it's using a restricted set of Markdown, it can run a validator against the code to make sure that your HTML is actually only using the restricted libraries and not something else. And if so, then it gets cached on the edge and served, right now at least, served in the Google search results in the news section, and you get a little lightning bolt next to the articles, and the pages effectively load instantly once someone clicks on them.
So Google does a good job in promoting these projects that use AMP by serving them up in a nice way in the search results. Is that the way to promote it as well?
Yeah, I mean, that's certainly a way to encourage adoption, but it also drives for a much better, as far as like the news results, a much better user experience, because the way the AMP containers work, the news search results can load them in an iframe, and as you slide left and right, you can actually flip between AMP pages, and they're all sort of instant loading, so you get a much more seamless integration even in the search results page.
So that means if I come back to my question, thanks for that little excursion into AMP and mobile performance. And actually I had mobile performance on my topic list as well. But remember, people out there, all the initial rules that Steve and Pat and others a couple of years ago put out there are still all relevant. Make your pages lean, reduce the number of resources on the page, use browser-level caching, optimize your images. Sprites, I guess, are still a big thing. What about the domain sharding? Domain sharding was one thing back in the days where Steve actually said, with domain sharding, you can basically force your browser to open up more connections in parallel to download content. Is that still relevant, especially in the era of HTTP 2? Or is that something we should not do because basically you're just bombarding your servers with too many parallel connections that don't really make sense?
So it doesn't disagree with HTTP2. It's a little tricky. So HTTP2 will do what it calls connection coalescing, where even if you serve multiple domain names, if they all serve from the same IP address and you have a shared certificate that includes all of the names on them, it won't open new connections, and it'll just reuse the existing connection. So in theory, you can still do domain sharding and have all of the connections collapse together into one HTTP2 connection. You do still pay the cost of the DNS lookup, which is a little unfortunate. That said, domain sharding itself has kind of gone a little off of the deep end. And we in Chrome have protections in place to make sure that even if you've done domain sharding, we won't load more than 10 concurrent images across no matter how many domains you have, because once you open up too many concurrent domains, you start defeating lower level TCP congestion control. And we've seen a lot of cases where on slower connections, you'll actually flood the connectivity to the point where the servers will send duplicate data, and you end up with well over twice as many bytes on the wire to deliver like a 2 meg web page actually ends up sending 4 megabytes of data because of protocol inefficiencies and stuff.
That's interesting.
From doing too wide domain sharding. So we ended up having to put, and I think Etsy has a good blog post where that they put out about how they were sharding their image galleries across a whole bunch of domains and decided, maybe 2 is a better number, because they were seeing cases where you were getting what we call spurious retransmits, and it actually slowed down their page loads. So it's a really fine line to walk. If you are going to domain shard, I wouldn't do more than 2. That said, there's not that much of a benefit these days. It was really important when browsers would only open 2 connections per domain. It's been probably a decade plus since that's been the case. They all open at least 6. Edge and some of the other browsers, I think, will ramp up even higher than that. So for the most part, and odds are you're actually serving a lot of content from a whole lot of different domains. So the costs of each one of the domain shards usually ends up being a DNS lookup, a separate socket connect, and if it's HTTPS, a separate TLS negotiation. To be able to make up for those additional costs in concurrent downloads actually ends up taking a lot of benefit away from doing the sharding. So I'd start with no sharding, and maybe if you find a specific use case where you do see a lot of benefit from doing it, take a look at it. But starting out with not sharding is certainly a much better starting place.
That's a great advice. And maybe some other additional new things that you said that just popped up in the last year or two. Any hot topics that people talk about?
So, I mean, it's not really new from the technology perspective, but emerging markets are huge. All of the new internet usage is coming from emerging markets. The U.S. and Europe, for example, is well saturated, and even sort of the older Asian markets like Korea and Japan are all well saturated with internet penetration. You're talking 80-90% plus saturation levels already. So all of the new internet users are coming on from India, China, Brazil, Mexico. And for the most part, they're mobile only, not mobile first. The phone is the only internet device that they have. It's their first experience on it. And so you end up, and the networks are 3G-ish, sometimes 2G. You get a lot of cases where they use their data bandwidth up and halfway through the month, and then all of a sudden what was a fast connection ends up being a slow connection because they get dialed back. Or they also have to pay for data packs and all of that kind of stuff. So data becomes a really important aspect to the web these days. And we're starting to see, it's kind of interesting that it's kind of what's old is new again. But a lot of the mobile performance issues are the same kinds of things you used to see back in the dial-up days. And so the transcoding proxies, things like Opera Mini and UC Mini, are really popular because they recompress all of the images. to make the pages smaller so that they can actually be consumed in these networks. And it's not necessarily just a matter of less data for them to pay for, although that's very important because data ends up costing them a much larger percent of their take-home pay than it does in the US, for example. But unless you actually try browsing your pages in some of these environments, and I do highly recommend like using a 2G profile in Chrome DevTools or Link Conditioner in Apple or in WebPageTest, use the slower profiles to get an understanding for exactly how painful it is. It really is a matter of them being able to consume the content at all or not. You're talking about changes in start render time from 1+ minute down into the 10-second range when you start using some of these compression proxies. Or if you have an actual fast website that's aware of the slow connections that the users are on, or just a well-optimized site that's delivering as little content as possible as quickly as possible, you can still have fast experiences. But I mean, if you take a look like at the HTTP archive over the last 5 years or so, average website's gone from 700K to 2.5 megabytes. It's crazy. We don't really notice this on fast connections per se, but on slow mobile connections, a 2.5 megabyte page on a 2G connection, it's not a matter of it just taking longer. It's not going to load. The user is never going to see your content.
And actually, I mean, there's a lot of amazing points that you just brought up. And then you said we are fortunate here in the US and in Europe with big bandwidth, but also I think you in your Velocity presentation, you had a tweet, I'm not sure who it was, but basically also if you are in the US and even though your phone is on an LTE connection, but if you're out of your data plan, you basically throttle down to lower bandwidth. And that could also be very...
Yeah, and it's actually interesting timing on that because Verizon, AT&T, and I think all of the players are just now launching unlimited data plans that throttle, even for tethered connections. So once you exceed a certain data limit, instead of charging you more, like an insane amount, they'll just throttle you down to really slow speeds.
Yeah, and I've been on even 3G connections these days, and it's almost... you say it takes long. I kind of say it's unusable. It's funny, though, because when I got my first iPhone, 3G was blazing fast, but obviously the pages were much smaller and everything worked, was workable on a 3G. But even these days, once I get away from the city, heading towards the mountains or anything, and you hit one of those 3G-ish areas, it's extremely painful.
Yeah.
Yeah, and it's a combination. The web itself has gotten a whole lot bigger, but also the networks. When the 3G networks were completely unloaded, things were actually really fast. You can get a fast 3G connection if there's no one else on the network. As the networks become more congested with users, they end up, even what's advertised and connected to as a 3G network ends up having fairly low performance versus the specs. And certainly in the emerging markets where they're getting millions and millions of new users continuously, it's even more of an issue.
You mentioned Opera, especially. I remember Bruce Lawson, I think is his name, from Opera, who had a great keynote at Velocity this year. And he actually talked exactly about the emerging markets and what they are doing now. Do you think is there a way that we here in Europe and in the US should also look into these practices, what Opera is doing with basically packaging up, optimizing content, packaging it up, and actually sending the optimized content to the browser? Are these some techniques that actually also make sense in general, or would this go too far?
No, I mean, so Google already has a light version of their search results page, for example, that they serve when they think a connection is slow. That basically has a lot of the JavaScript stripped out, and it's sort of more what the classic search page used to be. You type in your query, you hit search, and you get results without whatever fancy interactive features and stuff. And they've also got like transcoded versions of landing pages that if you go on search results and click on a page, and we know you're on a slow connection in an emerging market, we'll rewrite someone else's page for them just to give the user a fast experience. But for the sites themselves, it's all of the basics. It's no different than what you're doing if you're trying to optimize for a fast connection, even reduce the number of requests, reduce the head blocking resources, all of that kind of stuff. It just takes it to a whole new level. At least these days, it's the same level that it was 10 years ago, where if you want to keep all of your rich interactive features and you need all of your JavaScript for your high-end users, then you might have to start making a decision if you want to segregate your traffic and detect a slow connection and fall back to a more basic experience, almost like the M.dot days, but God, please, not redirects and not actually M.dots. But do you have a rich and a light experience, or can you lighten up your rich experience? Can you do things incrementally and go, okay, we're going to start at, and it's progressive enhancement isn't new, right? But can we deliver the basic content, and then if the page is loaded within X seconds or whatever, decide, okay, this connection's fast enough to handle the rich experience, deliver all of the JavaScript and whatever else is needed to build up to progressively enhance to the rich experience.
And I remember seeing in your presentation, even taking into consideration things like battery, how much battery is left, right? Because that's going to play an important factor in rich media.
There's all sorts of battery left, CPU, GPU. And a lot of this stuff is now detectable from inside of the browser. You can sort of make a lot of these decisions. And even if you're serving video, making the decision between 60 frames per second and 30 frames per second has a huge impact on battery, for example.
Now, another big topic that I remember from velocity, and I think you also covered it in your presentation, is ads and ad blockers, and kind of the browser vendors move forward to actually try to build a lot of these things natively into the browser to actually speed up. Well, on the first thing, block ads, but then also speed up performance with it. Anything you want to share here, especially when it comes to front-end performance, what the impact of ads is, and why browser vendors actually move into that direction of providing browser or ad blockers natively?
Sure. So it's no secret that ads tend to slow down pages a lot. And certainly when you're doing your progressive enhancement, one of the things you probably want to look at is when you inject your ad tag, it's probably a good idea to see how long it's been for the page to get to that point and decide if you want to inject it at all, if you want to inject maybe a text fallback or the rich experience ad, and do smart things about what kind of experience you deliver. But at least from the Chrome side of things, we're not, at least that I know of, actively trying to block ads. But what you will see is there's a bunch of things that we call user agent interventions. And if you search for like Chrome interventions, you'll basically see a list, and there's like intent to ships and intent to experiment with and stuff like that for all of them. But what we end up trying to do is target behaviors where we could optimize for the user experience, and that's where the user agent intervention part comes in, is regardless of what the developer told the browser to do, if we think it would be a much better user experience to do this other thing instead, we maybe explore being not spec compliant and violating what the developer thought they were asking us to do. Mm-hmm. And so a good example of that is document.write as a feature in general. It's horrible for performance. It breaks preload scanner and all that kind of stuff. It happens to be used a lot by ad networks, but it's also used by tag managers and a whole lot of other things. From a browser perspective, JavaScript execution, we can't figure out what the code is going to do. So we have to sort of stop all of our predictive stuff and just execute whatever is being done. And you end up with long blocking sequences. And in slow connections, it's a really bad experience. So there's in-flight experiments to go, okay, well, what if we disable the ability to document.write at all, or at least with some heuristics, in certain conditions, like if the user's in an emerging market or if the user's on a 2G connection, what's the impact of blocking document.write? Do they browse more? Do they consume more content? Do they abort less? And the answer to all of those is yes, by a huge margin. The page load times come down in half almost, or at least the time to start renders and things like that. And you see a lot more engagement and a lot more people consuming content. But there's also things like scroll handlers. Maybe we'll ignore synchronous scroll handlers when you're scrolling. A lot of other browsers do as well, because those can cause janky scrolling and things like that. So the browsers are starting to become more opinionated to try and deliver the user experience for cases where it looks like the web has failed the users. Mm-hmm. I think is probably the best way to put it.
Cool. Well, I think, as you said, we are all very passionate about the topic, and I guess we could go on. I mean, I still have a lot of questions on my list, but I really think as a summary for folks that are still either are new or have been in this field of front-end performance optimization for a while, or are new, please check out the video, the recording from Pat. What he did at Velocity. I'm sure the New York. What are you doing in New York besides redoing the one with Tammy? Are you also redoing the front-end performance talk?
No, I mean, I have a 2-day training I'm doing with Tim, but that's just more on bringing people up to speed on all things web performance. Okay.
So. But maybe as a summary to kind of conclude this talk, don't forget the basics, right? Obviously, that's the most important thing. Then you brought some good things up on mobile. HTTP2 will be changing a lot of things. I'm very fascinated that we already have a good penetration of HTTP2. I really like what you mentioned about emerging markets and what they do down there. That's quite phenomenal. Then what else did you mention? Just to make sure that people don't forget, that Chrome interventions is very interesting.
And we talked some about the AMP pages.
Yeah, exactly. Google for AMP. So I think that the page actually that I found, it's the ampproject.org, right? That would be one page to start. Anything else that we want to make sure that our listeners don't forget and that they do in order to make the web a better place?
I'd just probably throw out, we hadn't talked about it yet, but I want to make sure people are paying attention to priorities in HTTP2 and number of third-party resources are sort of the two big things to watch out for with HTTP2 as it becomes more popular. The protocol itself and the browsers heavily depend on the server doing intelligent ordering and things with the browser will attach a priority and dependency information to every request, but it's a requested priority, and it's up to the server to honor that or at least do intelligent things with that. If the server blindly shoves all of the resources down, you're going to have a really bad experience. And I fully expect that's going to be one of the differentiating features of HTTP2 implementations on the server side. The other thing to watch out for, and we don't necessarily have good answers for yet, is third-party content with HTTP2, where HTTP2 coalesces all of the requests to a single origin, but once you have 30 different third parties on your page, you've got 30 different HTTP2 connections that aren't necessarily prioritizing against each other, and things start to fall apart, and I expect you're going to see browsers evolving in that space, but we also sort of need to figure out how do we make sense of that.
Yeah. And that's cool. And I mean, one topic that we didn't cover at all, which is a topic that we've been talking about in the early days of the Dynatrace Ajax edition when we had that tool is the whole JavaScript performance, JavaScript execution. I mean, obviously, we could talk about this forever.
Yeah, and I mean, it's scary how much that's actually becoming as mobile phones. I mean, they're powerful, but not compared to the amount of JavaScript we're throwing at them. So it's becoming a very big deal.
I see a lot of our users, trying to figure out memory problems, memory leaks in JavaScript, how to diagnose that, and then how that JavaScript obviously runs on the thousands of devices out there. And I think that's obviously, this problem is not getting easier, right? The amount of device combinations and permutations we have out in the wild. That's critical. Oh. All right. Hey, Brian, anything else from your side to kind of wrap this up?
Yeah, I wanted to make this go a little juvenile here for a moment, going back to when we were talking about sharding. I wanted to make sure people knew that was S-H-A-R-D and not S-H-A-R-T. ING. Both of them are equally not advisable. And if you're not sure what the T is, go ahead and look it up. Urban Dictionary will probably give you a lot of colorful definitions there for you. The other funny thing I want to just bring up, Pat was talking about going back to the basics on web performance, and still seeing all those same mistakes or, the practices not being put into place. And it just strikes me how, once again, we're seeing everything old is... all the old problems are new again. And what I mean by this is, Andy, you do with the free trial, you see all of these same mistakes being made over and over and over and over and over and over again. N+1 queries, chatty database, people not handling their thread counts and everything on the back end. And just when people start getting it under control on their back end systems, which, I think by and large they still haven't gotten it under control, but for when they do get it under control, then they move into microservices and start making all the same mistakes again. So it kind of seems like human nature that no matter how many times people can put out a list of, the top 10 things to do for performance, people are going to naturally ignore them or, for whatever reason, not stay on top of them and not keep as good of a lookout or place the importance on prioritizing those. It just strikes me.
And I think one of the reasons is probably because we keep getting a new set of engineers out there all the time, right? I mean, the engineers that are now building the new cool SPAs might not be the same engineers that have been around 10 years ago when Steve Souders talked about web performance optimization. And
you would think these would be the fundamentals, though. You know what I mean? Like, okay,
yeah, but I agree, but I guess that's why we need to shout out. Keep shouting out the same things because there's new people that haven't heard them before, and
job security for us.
And I think we have a problem that the defaults aren't fast, right? So you actually have to know and think about it. And as sad as it is, I think that's part of what AMP is tackling, where you can't screw it up. And we need to sort of, I think, move the tooling and the infrastructure and everything to the point where even if they don't know what they're doing, they're not building a slow solution by default, right?
And that's also what I think, Brian, what you said. We keep finding in the Dynatrace world a lot of these performance problems, front end and back end, and what we build into the products now is basically when you are a developer or a tester and you test your app, then we automatically detect these patterns for your front end and back end and say, hey, you have too many images on the page. Hey, you have too many of the same database query 50 times through Hibernate. You may want to change the caching setting or the caching strategy. So we actually, as tool vendors, we try to advance and basically build this intelligence that we came up with over the years, and that we do pretty good when we manually step through the data. We try to put this into the products and basically bubble it up. So if a new engineer who just comes out of college, runs a quick test with WEBPAGETEST, maybe, hopefully, and then has Dynatrace in the mix, then he sees, hey, no caching, no browser-side caching defined, and on the back end, I have a misconfiguration in Hibernate. I wasn't even aware of it, but now I know. So I learn, and so I build better apps. So.
Okay, and if you're not following Pat already, Pat, your Twitter handle is?
Pat Meenan, P-A-T-M-E-E-N-A-N.
And obviously, as any listeners already know, I'm at Emperor Wilson, and we have at Grabner Andy. And if you have any questions, comments, anything on the show, you can reach us either through our Twitters or you can tweet hashtag Pure Performance at Dynatrace. Any show ideas, topics, if you want to be a guest, we'd love to hear from you. And I guess that's all I have. Andy or Pat, any final thoughts or closing words?
The only thing I want to say is, Pat, if you want to be on the show again, because I know you said you can talk performance forever, and if you want to just talk about a new topic, or if you have an update on stuff that you're working on, I'm very glad to host you again, because I think we just need to, as I said, educate the folks out there, and all the channels that we have, we should use them and make sure we make the web a better place, as you said earlier.
Yeah, I mean, thanks for having me. Like I said, I love doing this. So if there's anything anyone wants to hear more about, let me know. I'd be happy to come back and chat about it. Or hit me up in person at Velocity or something like that. But yeah, I love talking web performance.
Well, Pat, thank you very much for being a guest. We really appreciate it. And it was at least an honor for me to have you on. So thank you. Looking forward to future engagements. And if I can ever get out of the house, I'm really hoping I can get to see you at Velocity someday.
Thank you for all the listeners, and keep listening to us. Keep these websites up and running. Make them faster, and I'll see you soon or talk to you soon.
Yes. Bye-bye.
Bye.